Water found for first time on potentially habitable planet. Astronomers have for the first time discovered water in the atmosphere of a planet orbiting within the habitable zone of a distant star. The finding makes the world, which is called K2-18b, a plausible candidate in the search for alien life. Within 10 years, new space telescopes might be able to determine whether K2-18b's atmosphere contains gases that could be produced by living organisms. The lead scientist, Professor Giovanni of University College London, UCL, described the discovery as mind-blowing. This is the first time that we have detected water on a planet in the habitable zone around a star where the temperature is potentially compatible with the presence of life, she said. The habitable zone is the region around a star where temperatures are considered sufficiently benign for water to exist in liquid form on the surface of a planet. The new planet is just over twice the size of Earth, in a planet category known as a super-Earth, and has a temperature cool enough to have liquid water, between 0 and 40 C. K2-18b is 111 light-years, about 650 million miles, from Earth, too far to send a probe. So the only option is to wait for the next generation of space telescopes to be launched in the 2020s and to look for gases in the planet's atmosphere that could only be produced by living organisms. What is an exoplanet? Planets beyond our solar system are called exoplanets. The first exoplanet was discovered in 1992, orbiting a pulsar, a neutron star that emits electromagnetic radiation. More than 4,000 have been detected to date using several techniques. Many of these worlds are large planets believed to resemble Jupiter or Neptune. Many giant planets have been found orbiting very close to their stars line. The team behind the discovery looked to the planets discovered by the Hubble Space Telescope between 2016 and 2017. The researchers determined some of the chemicals in their atmosphere by studying the changes to the starlight as the planets orbited their suns. The light filtered through the planet's atmospheres was subtly altered by the composition of the atmosphere. Only K2-18b revealed the molecular signature of water, which is a vital ingredient for life on Earth. Dr. Angelos Ziaras, a member of the UCL team, said that finding water in the atmosphere of a potentially habitable exoplanet was incredibly exciting. Other astronomers, however, dispute the claim that the planet is potentially habitable. One analysis indicates that planets that are 1.5 times the mass of the Earth are unlikely to have a rocky surface. There is also concern that K2-18b's size and gravity would make it difficult for the world to support life. Other critics suggest that the planet should not be classified as a super-Earth, but as a mini-Neptune instead. This is a class of planet that is typically more massive than a super-Earth. It includes worlds that are up to 10 times the mass of our own planet. Professor Donetti, however, maintains her view that the new world is potentially habitable. She said it had a mean density that's comparable to that of Mars, which is composed of silicates, and Jupiter's moon Europa, and much higher than Neptune's. K2-18b cannot be classified as a mini-Neptune. It is more likely to be a planet with an interior of rock and ices. These types of planets are sometimes called ocean planets, she told BBC News. Now, whether this planet really has an ocean at the surface or rock, we cannot tell with current observations, but having water in the atmosphere is a good start. But it is a view that Dr. Laura Kridberg, of the Center for Astrophysics at Harvard University, does not agree with. The interior of the planet is much more like Neptune. Pressure and temperature increase with depth, so that before a rocky surface is reached, it is too hot and too high pressure for complex molecules like DNA or any of the other building blocks of life to form, she told BBC News. Professor David Charbonneau, also from Harvard University, said the fact that K2-18b's atmosphere was detected was proof in itself that it could not support life. If the planet had a thin secondary atmosphere similar to Earth, it would be so thin that Hubble couldn't detect it. Long haul, another issue is that astronomers can't agree what conditions are needed for habitability. We only have the Earth to go on, but life may also be possible on other types of worlds. It is likely to require a survey of the chemical composition of, perhaps, hundreds of worlds and an understanding of how they are created and evolve, according to Professor Donetti. The Earth really stands out in our own solar system. It has oxygen, water and ozone. But if we find all that around our planet around a distant star, we have to be cautious about saying that it supports life, she said. This is why we need to understand not just a handful of planets in the galaxy but hundreds of them. And what we hope is that the habitable planets will stand out, that we will see a big difference between the planets that are habitable and the ones that are not. In a first for astronomers studying worlds beyond our solar system, data from the Hubble Space Telescope have revealed water vapor in the atmosphere of an Earth-sized planet. Although this exoplanet orbits a star that is smaller than our Sun, it falls within what's known as the star's habitable zone, the range of orbital distances where it would be warm enough for liquid water to exist on a planet's surface. That discovery, announced this week in two independent studies, comes from years of observations of the exoplanet K2-18b, a super-Earth that's about 111 light-years from our solar system. Discovered in 2015 by NASA's Kepler spacecraft, K2-18b is very unlike our home world. It's more than 8 times the mass of Earth, which means it's either an icy giant like Neptune or a rocky world with a thick, hydrogen-rich atmosphere. As it makes each transit, the star's light shines through K2-18b's atmosphere. But not all that starlight makes it through, since chemical compounds in the atmosphere absorb light at telltale frequencies. Water, in particular, absorbs near-infrared light at specific wavelengths, creating a visible sign of water vapor. Between 2015 and 2018, Benck's team used Hubble to monitor 9 K2-18b transits. When they stacked up the transits datasets and cleaned them up, they found that telltale sign of water vapor. Benck and his colleagues have posted a version of their study on the arXiv, a repository for scientific preprints. Chance of Rain independently, a team led by Zioras and Inga Waldman at University College London used the same Hubble data to do an analysis of their own, which appears today in Nature Astronomy. Like Benck's Deem, they also found evidence of water vapor in the atmosphere of K2-18b. In their paper, Zioras and Waldman say that statistically, there's only a 1 in 3,000 chance that the results are a fluke. In addition to bolstering the search for life-friendly exoplanets, that discovery may open the door to understanding alien weather. Benck's team points out that conditions in the atmosphere of K2-18b might allow for the formation of liquid water droplets, and maybe even rain. Water vapor clouds have been found before in brown dwarfs, hulking objects that hover on the border between planet and star. If the results hold, K2-18b would be the first confirmed exoplanet with clouds of water vapor. Both research teams say that the studies make K2-18b an ideal target for follow-up missions, including NASA's upcoming James Webb Space Telescope and the European Space Agency's Future Aerial Space Telescope. Unlike Hubble, these telescopes will be able to see other atmospheric gases, such as methane, ammonia, and carbon dioxide, and potentially even chemical markers for life. Hey guys, I need your help. Please subscribe this channel. I will always grateful for your kindness. have a great time ahead.